So here is the first part of our review for the midpoint of Unit 7, where we're talking about negatives, absolute value, and inequalities. So hopefully you've already completed the first 2 pages, and you are going to be using this video to check your work. So number 1 says select all of the numbers that are greater than -6 and explain how you know. Okay, so when we talk about rational numbers, and rational numbers include both positive and negative numbers, it's really helpful to have a number line out in front of you. So we can see that negatives are to the left and positives are to the right. And it's important to note that when you look at a number line, there's a few different rules that I just want to point out that we should always remember. 1, left is less. So as negatives go to the left as we count back, -1, -2, -3, the further to the left you go, the smaller the numbers are actually getting, which leads us to the second point. The larger, in quotations, the negative, the smaller it really is. So negatives kind of function in an opposite way that positive numbers do, right? So if we look at positives, we all know that 10 is greater than 1, right? 10 apples is more than 1 apple. However, negatives actually function in the opposite way. -10 is actually less than -1. So that's why when I say the larger the negative, so it seems larger, right? You're seeing 10, and we know when we're talking about positives, 10 is greater than 1. But negatives, it's the opposite. -10 is less than -1. And if we want to think about that in terms of like money, let's say, so if we talk about debt, debt is the idea of owing someone money. So someone who owes someone $10, they have -$10, has less money than someone who only owes them $1, meaning they have -$1. All right. And the third important rule, positives are always greater than negatives, no matter what. Any positive number, no matter how small, is larger than a negative number. So now let's go back to this. So select all the numbers that are greater than -6. I know A is greater than -6 because positives are always greater, no matter what. Now I have -6. Well, -6 and -6 are equal. So it is not greater, it is the same. So I will not circle that one. -12. So that one seems like it's larger, right? 12 is greater than 6. However, negatives, like we said before, the opposite. The larger the negative, the smaller it really is. So -12 would be back here on the number line. -12 is actually smaller than -6. That's a really common mistake that people make. Next one, 1/4. That one is greater than -6. For the same reason as above, positives are always greater than negatives. Now the next two, -1 and -2. -1 is greater and -2 are both greater. And both for the same reason, we could say they are to the right of -6 on the number line, or we could also say the larger the negative, the smaller it is. So once again, because these are over here, -6 is over here, -6 is less than them. So these ones would both be larger. All right. So now, write a positive or negative number to represent each change in elevation, and then write the new elevation. So, a diver was at sea level. So, before we move on, let's look at these 2 number lines, okay? So, oftentimes when we talk about negative numbers, we are talking about them in context. So, 2 common ways that we talk about negative numbers is in terms of elevation, how high or low something on the planet is, or we talk about temperature. So this one is talking about elevation. So when we talk about elevation, sea level is a 0-foot elevation. Sea level means where the oceans lie, and everything on the planet is compared to the level of the ocean. So if you have a negative elevation, that means you are below the surface of the ocean. If you have a positive elevation, that means you are above the surface of the ocean. So the diver was at sea level, so they were at 0. They were swimming on by the waves, and then swam down 20 meters. So if you go down, that is a negative change. So they went down 20. So that is negative 20. And their new elevation, if they started at 0 at sea level and went down 20, 0 minus 20 is negative 20 meters. That's their new elevation. Now the diver swam back up 15 feet. So if you swim up, you're going positive. So that would be positive 15 would be the number that represents the change. And negative 20 plus 15 would get us to negative 5 meters, would be their new elevation. So they're still below the surface of the ocean, but they are a little bit higher. They're just 5 meters below now. And now the diver swam down 43 feet to catch a fish. And I'm sorry, I'm bouncing back and forth between meters and feet, which I shouldn't have done. I've been using meters, so let's just imagine they say meters instead. That's what we'll stick with. So the diver now swam down 43 meters, we'll say, which would be negative 43, because anytime you go down, that is a negative change. And so they were at negative 5, and they went down 43 more meters. So they would now be negative 48 meters, would be their new elevation. They are 48 meters below the surface of the ocean, and then they swam back up to sea level. Well, I know that they're currently at negative 48 meters, so if they swam back up to sea level, then they would have to go back up those 48 meters to be back at sea level, which is 0. Alright, so now for number 3, people were pretty comfortable with this before. For each number, we are going to name its opposite. And so the definition of an opposite number is the number that is an equal amount away from 0 on the number line. So if we look at a number line, 2 and negative 2 are opposite numbers because they are both 2 units away from 0. Negative 3 and 5/10, that would be in between the negative 3 and negative 4, and 3 and 5/10, which would be here, are both 3 and 5/10 or 3.5 units away from 0. So those would be negative numbers. So essentially, it's just the same number with the opposite sign. So the opposite of negative 5 is 5. The opposite of 28 is negative 28. The opposite of negative 10 and 4/10 is positive 10 and 4/10. The opposite of 875 thousandths is negative 875 thousandths. The opposite of 0 is 0, because 0 is its own opposite. And the reason why is because the definition of opposite is a number that is an equal amount away from 0. Well, 0 is 0 units away from 0. It's itself. So there actually is no negative version of 0. That is the origin. That's just the middle. So that would just be 0. And the opposite of negative 8,003 is positive 8,003. And now for our last activity. Problems like this have kind of gotten us before in the past. So you can see here that we've got positives, we've got negatives, and we also have numbers in these weird little bars here. These little bars here are called absolute value. That's absolute value notation. And absolute value refers to a number's distance from 0. So when we see these absolute value bars, we actually kind of have to reorient our minds, okay? So when we see just a normal positive or negative number, we're just looking at that number's value, right? -1 and 5/10 is a number's just normal value. Now when we look here, we would say this as the absolute value of -5/10. And whenever you see those bars, you need to reorient yourself, because you're not just saying the value of -5/10, you are saying what is the distance from 0 of -5/10. So because we're not looking at this, just this number, we're thinking about its distance from 0, we need to find its distance from 0 before we can actually plot it on the number line. And -5/10, 5/10 is a half, so that would be here, and that is 5/10 away from 0. So whenever we talk about absolute value, it's always positive. We always measure the distance from 0 in positive numbers. So if you ever have an absolute value of a negative number, you just need to convert it to its positive form, because it is that many units from 0. And so we have one more absolute value, the absolute value of -1, and that it would be here, which is 1 unit away from 0. Now we are ready to plot our numbers. So -1 and 5/10, it's negative, so it goes back, and that's 1.5, so that would be in between -1 and -2. It is halfway to -2. Now 3/2, so that's a fraction. We could notice that that is, if we converted that to a mixed number, that could be 1.5, or that could also be 1 5/10. And if you ever need help converting fractions, remember fractions are division, and if you were to do 3 divided by 2 in your calculator, it will convert it to a decimal value for you. So here's 3/2. The absolute value of -5/10, we've already said the absolute value of it is 5/10, so that would actually be here. Because absolute value, whenever we find it, it's always positive. -4/3, so that would be 1 1/3 if we converted it to a mixed number, or if we did that division, 1 and 3 repeating, so it's negative. So that would be -1, and then kind of 1/3 of the way to -2. Absolute value of -1 is actually just 1. That would go there. And then the opposite of -2, so once again, the opposite is a number that is an equal distance from 0. So here's -2. The opposite of it would be 2. Go here. Alright, now go ahead and complete the next 2 pages before watching the next video to check your work.